Okay, today we're going to look at the point of intersection and we're going to solve for it algebraically. There's more than one way to do this, but today we're going to try one version. So basically, when two equations describe the relationship between two variables, there's usually a single point that satisfies both equations simultaneously. So unless the lines are parallel, they will cross somewhere. And when they cross, that's called a point of intersection, and that's our solution. Okay, so yesterday we looked at graphing. So you found the slope and the y-intercept, you graphed them, you found where they crossed. Today, we're going to put both equations into slope y-intercept form. We're going to set them equal, we're going to solve, and then we're going to substitute that answer back into one of the other equations to solve for the other one. So let's try it. Here I have two equations, y equals 3x plus 4, and y equals 5x plus 2. So if I make my y equals 3x plus 4 my blue line, then I start, remember that's my y-intercept. So I start at 4, 1, 2, 3, there's 4 right there. And the slope is 3, so 3 over 1. So I'm going to go up 3, 1, 2, 3 over 1. 1, 2, 3 up over 1. And that's enough to give me a line. So let's see. There's line 1. Okay. And then we're going to do the same with our other line. This time, I don't know, I'll make it green. Sure. We start at our y-intercept of 2, right? We always start there. And then a slope of 5, so that's really 5 over 1. So we're going to go at 5. 1, 2, 3, 4, 5 over 1. Oh, look, they crossed. 1, 2, 3, 4, 5. Okay, go that way. 1, 2, 3, 4, 5 over 1. Good. That gives me lots to draw my lines with. So let's see down here, up and through. And there we go. We found our point of intersection. So our point of intersection is right here where they cross. There we go. That's our point of intersection. And that happens at 1, 1, 2, 3, 4, 5, 6, 7. 1, 7. And there's our point. Now, algebraically, we're going to do this by setting the two equations equal to each other. So I'm going to set basically the y of line 1 equal to line 2. So I'm going to have y equals y. So I've got 3x plus 4 equals 5x plus 2. Now let's rearrange. We know how to do that. So I'm going to minus 5x from both sides. I'm going to bring it over here. So that means I now have negative 2x plus 4 equals 2. I'm going to bring my 4 to the other side. So I'm going to do minus 4 on both sides. So all right, so now we've got negative 2x on this side equals 2 minus 4 gives me negative 2. Okay, so let's divide both sides by that negative 2 that's in front of the x. And we're left with x equals 1. Hey, look, x equals 1. Nice. There's our x. So we got it right. Perfect. All right, so now what we want to do is we are going to sub x equals 1 into, pick a line, any line, doesn't matter, how about line 1, into line 1, and then we're going to solve for y. So y equals 3x plus 4. So now I'm going to sub x equals 1 into here, so I get 3 bracket 1 plus 4. 3 times 1 is 3, plus 4, final answer, 7. Oh, look! Y was 7. Oh, we got it right! Perfect. Therefore, 1, 7 is the point of intersection. And the point of intersection is the solution. Awesome. Okay. So now we just want to make sure that we can, that we found the right answer. So the solution, we need to check if the point of intersection satisfies both equations simultaneously. So both of them at the same time. So first equation was, I don't know, what was it? 3x plus 4. So in equation 1, so our left side is y, and our right side is 3x plus 4. Equation 2, the left side was y, and the right side was 5x plus 2. X plus 2, and we're checking a point of intersection of 1, 7. So let's see. y was equal to 7, x was equal to 1 plus 4 gives me 3 plus 4, that gives me 7. Good, correct. Other one, y is equal to 7. Right side is 5 times 1 plus 2. That gives me 5 plus 2. Oh, that gives me 7 as well. Good. Therefore, 1, 7 is the correct solution. Good, so that covers basically everything we need to do. Let's do another example. Solve a pair of equations algebraically. Check your solution. Let's see. So here I've got line 1 is 7x plus 5y equals 9. And line 2, 7x plus 4y equals 4. So remember the solution style that we're going to do today is we're going to turn everything into y equals mx plus b, and then we're going to set them equal to each other. So let's rearrange. If I'm going to bring that to the other side, I have to minus 7x on both sides. So I'm left with 5y equals negative 7x plus 9. Divide by 5, divide by 5, divide by 5. Y equals negative 7 over 5x plus 9 over 5. Okay, let's look at line 2. So again, we have to move it to the other side. So minus 7x on both sides. So you get 4y equals negative 7x plus 4. Divide each term by 4, and you've got y equals negative 7 over 4x plus 1. So there's my line 1. There's my line 2. I haven't done anything other than rearrange them. So now I want to set them equal to each other. So I want to make line 1 equal to line 2. So y equals y. So that means negative 7 over 5x plus 9 over 5 equals negative 7 over 4x plus 1. Okay, so yeah, it's fractions, but we can do this. It's the same skills. And you guys know how to handle fractions, so we're good. So let's see, I'm going to plus 7 over 4x to both sides, plus 7 over 4x to both sides. And what does that give me? Hang on here, I'm going to come up here. So that means I've got negative 7 over 5x plus 7 over 4x, and I haven't touched that 9 over 5 yet, equals 1. Oh, okay. Let's move this to the other side. So I'm going to minus 9 over 5 to both sides. And now I'm looking at negative 7 over 5x plus 7 over 4x equals 1 minus 9 over 5. Okay, sure. Yeah, we can handle this. Hang on here. All right, I just reorganized so I had enough space here to work. So let's see, if I'm going to turn these guys into common denominators, well, I'm going to have to times those guys each by 4, these guys each by 5. Oh my goodness, what a mess. Let's see. Let's bring that up here. And I now have negative 28 over 20x plus 35 over 20x equals, turn this into common denominator, so times top and bottom by 5. So I now have a 5 over 5 minus 9 over 5. That's a 5, by the way. Okay, good. So let's see, 35 minus 28 gives me 7 over 20. X equals 5 minus 9 gives me a negative 4 over 5. Almost done here. So let's see, instead of dividing by 20, we're going to times both sides by 20. Instead of timesing by 7, let's divide both sides by 7. And what do we get? That's all gone. So I now have x equals 5 this out there's for negative 16 over 7. Okay. Okay. Now I'm going to sub x equals negative 16 over 7 into which equation? Doesn't matter, doesn't matter. No, it really doesn't. Let's just sub it into equation 2. Sure. So equation 2 looked like, I'm going to use the rearranged version, y equals negative 7 over 4x plus 1. X we just discovered is negative 16 over 7 plus 1. Oh, look, lots of things cancel. That's exciting. 7 and 7 cancel. 4 goes into 16 4 times. So what do we got? Positive 4 plus 1. So y is equal to 5. Nice. So final answer. Therefore, what was my x? Negative 16 over 7, comma, 5 is the point of intersection. Hey, that's pretty cool. Well done. All right, let's do this one. So here I've got this line is x equals 10 minus 3y, and I'm going to call that one line 1. And I've got x equals 8 minus 2, so I'm going to call that line 2. And notice I already have x equals everything, so instead of rearranging, you know what? Let's just set x equal to x. Sure. So line 1 is going to be equal to line 2, so that means x is equal to x. So that means 10 minus 3y equals 8 minus y. Ah! Sure, why not? So let's see, let's get our y's together. So I'm going to plus y to both sides. So that gives me 10 plus 2y equals 8. And let's take our 10 to the other side. So we're going to subtract 10 from both sides, which leaves me with 2y equals negative, is that 6? And then we're going to divide both sides by 2. And now I have y equals negative 3. Beautiful. Okay? So now I'm going to sub y equals negative 3 into, I don't know, which line do you want to do? Line 2 looks easier. Into line 2. So x equals 8 minus y. So 8 minus negative 3. 8 plus 3 gives me 11. Nice. Therefore, 11 comma negative 3 is the solution. Right? Because it is the point of intersection. Nice. Good stuff. All right, let's do a word problem. Ralph works part-time for a bike repair shop. He earns $2 for each tire he installs and $5 for each gear mechanism he assembles. So last week he did a total of 40 installations and assemblies and earned $110. So how many tires did he install? How many gear mechanisms did he complete? Okay, well, let's think this through here. We've got tires that we're talking about, and the tires are $2 each. Okay. We have gears, so they are each $5. Okay. And then we have a couple of totals here. We have a total of 40, and we have a total dollars. So that's going to play a big role here in what we do. So let's see here. What are we going to do? I'm going to say let x represent the number of tires, and I'm going to let y represent the number of gears. So if I do that, then I know that if I have my tires and my gears, add them up, I'm going to have 40 installations. So that right there is equation number 1. Is the numbers. Okay. Number of, right? And then in equation number 2, I'm going to look at the money for equation number 2. So for equation number 2, I've got $2 for the tires. So I've got 2x plus $5 for the gears. So that'll give me 5y equals my total money, which is 110. So I now have 2 equations, 2 unknowns. We can totally solve this. Yes. So let's rearrange. Okay, we have to rearrange. So equation 1, let's see, we're going to move x to the other side, becomes y equals 40 minus x. Okay, let's look at equation 2 here. So this one requires a bit more rearranging. So let's see, we got a minus 2x from both sides, minus 2x, minus 2x. So that leaves me with 5y equals negative 2x plus 110. And then let's divide both sides by 5. So that means every term gets divided by 5. So that leaves me with y equals negative 2 over 5x plus 5 goes into that 2 carry 2. So 22. So now I have my equations. They've been rearranged. So this is still equation 2. This is still equation 1. So now we've got y equals for both of them. So now we can set them equal and we'll solve. Perfect. So I'm going to set 1 equal to 2, and then I'm going to solve for x. So let's see. I'm going to have y equals y. So I've got 40 minus x equals negative 2 over 5x plus 22. Okay? So, boy, oh boy, oh boy, we've got lots of things going on in here. Hang on, let me change. All right, so let's get our x's together. Let's get our 40 out of the way. So let's minus 40 from both sides. So that leaves me with negative x equals negative 2 over 5x minus 18. And then I'm going to plus 2 over 5x to both sides. So that means I'm going to have 2 over 5x minus, well, let's just do common denominator at the start. So 1 becomes 5 over 5 equals negative 18. 2 minus 5 gives me a negative 3 over 5x equals negative 18. So we're dividing by 5, so we're going to multiply both sides by 5. We're timesing by 3, so let's divide by the negative 3. So what does that give me? X is left behind equals 3 goes into 18 6 times. 6 times 5 is 30. So x is 30. Perfect. So now we're going to sub x equals 30 into one of the equations. Let's sub it in equation 1 because that's my smaller one. So that was y equals 40 minus x. 40 minus 30, 10. Therefore, 30, whatever the first thing was. What's the first thing? X was tires, right? 30 tires and 10 gears. Lovely. All right, last example. Let's do another word problem because they're tricky, but they show up all the time. Gretchen has 2 part-time jobs. She earns $8 at her per hour at her first job and $7 per hour at the second job. Last week, she worked a total of 19 hours and earned a total of $145. How many hours did she work at each job? So these two different totals are going to give me 2 different equations. So equation 1 is going to be based on her hours. So I know I've got hours of her first job plus the hours at her second job. And all of that's going to give me a total of 19 hours. Okay. Equation 2, I'm going to be basing it on the money. So I know I've got $8 at her first job and $7 per hour at her second job. And that's going to give me a total of $145. So if I think of it this way, I can clearly see that I'm going to need to let X represent the number of hours at her first job. And I'm going to let Y represent the number of hours at her second job. Okay, and if I do x and y this way, well, my first equation becomes x plus y equals 19, and my second equation becomes 8x, because it was $8 an hour, plus 7y, because it was $7 an hour, and I have a grand total of $145. 2 equations, 2 unknowns, we can definitely solve. Let's keep doing the same methods that we were doing. Okay, so let's rearrange. So equation 1 is going to become y equals negative x plus 19, because I have to move the x to the other side. So there's equation 1. Equation 2 is going to be a little bit trickier, so let's give ourselves a little bit more space here. We got to bring our x to the other side, so minus 8x to both sides. That leaves us with 7y equals negative 8x plus 145. We're going to divide everybody by that 7. So each term gets divided by the 7. So y equals negative 8 over 7x plus 145. Oops. 145 over 7. Set my 2 equations equal to each other. And we got it. So set equation 1 equal to equation 2. There's equation 1. Here's equation 2. Rearrange and solve. So we've got y equals y. Negative x plus 19 equals negative 8 over 7x plus 145 over 7. Let's put our x's together. So we're going to plus 8 over 7x to both sides. Okay. So that leaves me with 8 over 7x minus 7 over 7x. I'm just going to turn it into a common denominator there. Plus 19 equals 145 over 7. If I combine these guys together, then that'll make my life easy. And we just got to move our 19, so minus 19 to both sides. So that leaves me with 8 minus 7. Oh, that just gives me 1 over 7x equals 145 over 7 minus, let's see, 133 over 7. So how did we get that? So 19 over 1. So you got to times top and bottom by 7, right? Get the common denominator. Okay, so we're almost there. So we've got 1 over 7x equals 145 minus 133 gives me what? 12 over 7. Last but not least, let's get rid of that 7. Oh, look, it's going to go away on both sides. Yes! X equals 12. Oh, that's not so bad. Okay, now let's sub that back into one of our equations. I'm going to pick the easier equation because that's just way easier. So what do I mean by easier equation? Well, we've got this big complicated one, or we got the nice simple equation one. So let's do that. So we're going to sub x equals 12 into equation 1. So equation 1, let's remember, is y equals negative x plus 19. So let me kind of unzoom that so we can see what I'm about to do. And we are almost there, folks. Negative 12, so that becomes that, plus 19. 19 minus 12 gives me what? 7. So y is equal to 7. Therefore, she works 12 hours at her first job and 7 hours at her second job. Nice work. Okay. Not super easy all the time, right? We've got some complicated numbers that we worked with, but we're still using all these wonderful skills that we've been using. This is as far as we're going with solving equations like this. This is probably the hardest stuff we're doing. So if you can do this at least a little bit, then you're in good shape. Great work.